Okay, so I'm going to go over what we did in class with respect to reviewing solving linear inequalities. So our goals for this were to just solve simple and also compound inequalities and graph them on the number line. So first of all, we're going to talk about just what is an inequality. So for example, if I were to write -2 is less than 6, this little symbol here means less than, right? And the way I remember it is that less than starts with the letter L, and this symbol kind of looks like an L that's sort of tilted. So that's how I remember. Now, if it was less than or equal to, that's when there's the little line underneath it. So when you read this, you go from left to right. If the symbol looks more like an L shape, you're reading it as a less than or equal to sign. If it was the reverse direction, it would be greater than or equal to sign. Couple things to remember when we're doing inequalities is when you multiply or divide by a negative number, you must flip or reverse the direction of the inequality symbol. The graph of the inequality will consist of all the real numbers that correspond to the solutions of the inequality. So when you say like x is less than 5 or something, that just means that x can have many different solutions, but they're all less than 5. So there's two types of symbols that we're going to come across here. We have the less than sign, the greater than sign, and the not equal to sign. All of these would give you an open circle on a number line graph. And then we also have less than or equal to, greater than or equal to, or the equal to sign, and those would all have closed circles on the number line graph. So now if we were going to just demonstrate what these look like when we're graphing, if you have x and less than a number or greater than whatever that number is that x is being compared to is going to go on your number line. So we're going to have a 3, an open circle here. X is less than 3. So then you want to like think to yourself, okay, well, which side of that number would all the numbers that are less than 3 be found on a number line? So all the numbers less than 3, like 2, 1, 0, or negatives, would all be on the left. Okay, and of course that was an open circle because x is less than 3, but it cannot equal 3. So we would only color it in if it could also equal 3. For number 2, we have -4 as our defining number. This time it's going to be a closed circle because x is greater than or equal to -4. So not only can x be greater than -4, it also could equal -4 itself. All the numbers that are greater are to the right. So that's the side of the number line that will be filled in. And then finally, number 3 is just saying x cannot equal 2. So that would mean that x could be anything, just not 2. So there would be an open circle at the 2 to signify that it cannot equal 2, but all the other parts of the number line would be filled in because x could be anything else, just not 2. Okay, so when we solve and graph inequalities, we want to focus on getting that variable by itself. So here we have an n. So if I want to work towards getting that n by itself, I kind of want to imagine that there's a line here at my inequality sign, and that's like the two sides of my equation, just like that. So I want to get the n by itself on one side by moving everything to the other side using inverse operations. So the -9 or -9, to get rid of that, I would have to add 9 to each side. So now I have 11n is greater than, 22? And then we would divide by the 11, and I would end up with n is greater than 2. So that would be my answer there. So then I would put my defining number 2 on the number line. It's going to be an open circle since there is no equal to there. N cannot equal 2. It can only be greater than 2. And then I'm going to fill in the number line greater than 2. Okay, so then let's take a look at number 2. The x is the variable that we're trying to get by itself. So I'm going to kind of just draw my little imaginary line here just to kind of keep my two sides of my inequality situated. So in order to get this x term by itself, I need to move the 3 over first. And since it's a positive 3, I'm going to use my inverse operation of subtraction. So now I have negative 4x is greater than or equal to 4. And now to finish getting this x by itself, I need to divide both sides by this negative 4. Now this is where the directions in the beginning reminded us that anytime we divide or multiply by a negative when we're solving inequality, we need to reverse the direction of the inequality sign. So this is now going to become a less than or equal to. So my answer here would be x is less than or equal to negative 1. Now when I go to put that on my number line, my defining number is negative 1. It's going to be a closed circle because I have x is less than or equal to negative 1. And x is less than what all the numbers less than would be on the left. So it would look something like that. Okay, moving along. All right, so number 3, again, we have our variable here. We want to get that variable by itself. I kind of am just going to put an imaginary line through my inequality so I can kind of keep the two sides organized. And I'm going to add my 8 first because you always want to get rid of the numbers that don't have the variable being multiplied to them first. So 12 plus 8 is 20. And then I still have 5 times m. So now I can divide both sides by 5 so I can get m is less than 4. Now you might notice that I kind of read it backwards. Now a lot of people always like to have their variable on the left. It makes it a little bit easier for some people to read it or to graph on the number line. So if you ever end up with your variable on the right and you just don't like it like that, or maybe it's a multiple choice question and the answers are all written in the other direction, if you want to switch it around and put the m on the left and the 4 on the right, that's completely fine. Just notice that our sign here is like kind of pointing towards the m and opening towards the 4. So when you reverse the m and the 4 to opposite sides, you have to do the inequality sign has to change directions as well. So it's still m is less than 4 or 4 is greater than m. So now when I put it on my number line, I'm going to have the open circle at the 4. And m is less than 4. So all the numbers less than 4 are over here on the left. Okay, so now if we take a look at number 4, again, I'm going to just draw my little imaginary line through the inequality sign to keep it organized. Now this time I have a variable on both the left and on the right. So now there's 2 ways I can do this. Normally, I would like to move my smaller variable. In this case, 7x is smaller than 10x. I usually like to use the smaller one so I don't get a negative. But in inequality, sometimes people really want the variables on the left, so they might subtract 10x even though they're going to get a negative just to keep it on the left. It's really a personal choice. It doesn't really matter as long as your final answer is the same. So if I move my negative 10x, or I move my 10x by subtracting it, whichever way you want to kind of think of that, I now have negative 3x plus 9 is less than or equal to negative 12. Now I'm going to subtract 9. So I have negative 3x is less than or equal to negative 21. Now this last step here, because I had brought my x to the left, I have a negative x now, which is okay. I'm just going to divide by negative 3. I just have to remember that that's going to make me have to reverse the direction of my inequality sign because I divided by a negative. So negative 21 divided by negative 3 would be positive 7. Then I can put that 7 on my number line. It's going to be a closed circle because x can also equal 7. And x is greater than or equal to 7, so all those numbers would be to the right of that 7. Okay. All right, so then the next one, similar concept here. We just have a fraction in that problem, which is not a big deal. We're still going to kind of approach it in the same manner. So again, I'm going to draw my imaginary line through my inequality sign to keep it organized. Then I want to start getting this n by itself. So I'm going to move the 7 first. And then after I move my 7, I'm going to multiply both sides by the reciprocal, because that is how you are going to get rid of that fraction. So when I multiply here, I'm left with just my n. And on this side, I have 9 times 2, which is 18, 3 times 1, which is 3, and of course that would simplify to 2. Now notice on this one, I did not have to flip or reverse my inequality sign, and that's because I multiplied by a positive 2/3. So if I had multiplied by a negative, I would have had to do that, but in this case, it was only a positive. So now I'm going to put my 6 on the number line. It's going to be a closed circle. N is less than or equal to 6, so all those numbers over here to the left. And that would be my number line graph for that problem. Okay, so now for number 6. Now number 6 is a little bit different because I have a variable on both sides. I have one, I have one here and also here. But we also notice there's some parentheses, so in order to start solving this problem, we want to get rid of those parentheses. So I have 5 minus 5m, and on this side I end up with 12 minus 4m. Okay, and again, you might want to divide it just to kind of like keep it organized. So I have m's on both sides, but because it's an inequality, I'm going to go with bringing it to the left regardless, just so that it makes my answer look a little nicer. So I'm going to add 4m to both sides. So now we have 5 minus 1m is greater than 12. Then I'm going to subtract 5. So now I have negative m is greater than 7. But we're not allowed to leave this negative on the variable, so I'm going to divide by negative 1 to get rid of it. Now remember, because I divided by a negative, I need to change the direction of my inequality sign, so it's going to make it m is less than negative 7. So now when I put that on my number line, I have a negative 7 with an open circle because it does not equal negative 7, it's only less than. And all the numbers less than negative 7 would be on the left. Okay, so then we're going to move on to some compound inequalities. And compound inequalities are two simple inequalities joined by the word and or the word or. Now, if it's an and inequality, it's called a conjunction, and conjunction means like to bring things together. So if something is with that prefix like conjoin or something, it means that they're brought together. Disjunction is an or problem, and the prefix dis insinuates or implies that you're going to be separating or breaking apart. So when you see an and problem, you can easily recognize it when there are two inequality signs, and the variable would be in the middle. And so you want to get that variable isolated in the middle, and then you're going to actually have 2 points on your number line, and the variable will be shaded in between those 2 points. So for this example, you have negative 3, 2, negative 1, 0, and 1. Now I have a closed circle at my 1 because of the equal to. I would have an open circle at the negative 3, and my n could be anything in between those 2 points, so I would shade everything in the middle. Now, if I have an or problem, you're going to treat it as two separate problems. So this one here, I'm going to graph on my number line separately from this one. So before I do that, I'm just going to put some numbers on the number line. So I have negative 2, negative 1, 0, 1, 2, and 3. So if I'm going to graph this first one here, the x is less than or equal to negative 2. I'm going to do a closed circle on my negative 2. And x is less than or equal to that, so that's going to go to the left. on my other one, x is greater than 3, that's going to be an open circle on the 3. And then I'm going to be going to the right because x is greater than 3. Now, the way I kind of look at the graphs to know if I did it correctly, in most cases, your and conjunction type inequalities are going to be shaded in between 2 points. A disjunction or inequality is reminds me of 2 oars on a rowboat. So if you were rowing a boat and you have one oar sticking out on each side, that's what these little arrows kind of remind me of. So I think of an oar or an oar on a boat like that. Okay, so now we're going to solve and graph some of these. Okay, so we can see this first one here has 2 different inequalities. So that means that we're going to try to isolate the n by itself in the middle of those 2 inequalities. So when that happens, okay, so I want to add my 3 to get my n by itself, but where else does it add? Now, normally in an equation, there's 2 sides. So you would do whatever you do to one side, you do to the other. In a conjunction or an and problem, you have to add it to all 3 sections. So we're going to add it to the left, the middle, and the right. And the same thing would be true if we were subtracting or multiplying or dividing. So negative 12 plus 3 is negative 9. And I still have my inequality sign. And here my 3's canceled, but I still have that 3n. And then 15 plus 3 is 18. But our n is not quite by itself. Whoops. We still have this 3 here being multiplied. So we're going to divide by 3. But of course, we have to do that to both the left and the right sides as well. So negative 9 divided by 3 is negative 3. In the middle, we're left with just the n by itself. And 18 divided by 3 is 6. Now, as long as your smaller number is on the left, right, and your larger number is on the right, it's very easy to graph this on the number line. So all you need to do, since negative 3 is the smaller number and 6 is the larger number, I'm just going to plot a negative 3, leave a little space, then plot my 6. Of course, the negative 3 has a less than sign next to it, so that's going to get the open circle. But the 6 has the equal to underneath it, so it's going to get the closed circle. And then because n is in the middle of those 2 numbers or those 2 points, then we know we're going to shade in the middle. So let's try that again for the next problem. So on the next one, again, I just like to draw this like little imaginary pencil line here. I'm going to highlight the variable, which there's only one. It's already in the middle, so that's good. And now we need to get everything else out of the middle other than that x. So I'm going to start out by adding my 3 to all 3 sections, the middle, the left, and the right. So now I have a 6 is less than or equal to 4x, which is less than 16. Then my x is almost by itself, but it needs to get divided by 4 so that I can get my x completely alone. Now on this side here, 6 over 4 is 3 over 2. I have my x alone in the middle, and 16 divided by 4 is 4. Now 3 over 2 is fine. Normally we like to leave our answers as simplified improper fractions, but when we're putting them on a number line, it's a little bit better if you can figure out like where that would go. And so if it's a mixed number, it's a little bit easier to compare it. So you would want to put it as like 1.5 or 1.5 versus 3 over 2. So now you want to make sure that your smaller number is on the left, which is 1.5, and that is smaller than the number we have on the right, which is positive 4. So then we're just going to put those 2 numbers on our number line with a little space in between. Since the 1.5 has a less than or equal to next to it, it's going to get a filled in circle or a closed circle. The 4 does not have that equal to line next to it, so that is an open circle. And x is in the middle of those 2 numbers, so we are simply going to shade in the middle or in between those 2 points. Okay, so the next 2 examples are OR problems. So for these, we're going to basically treat them as 2 separate problems, but then we're just graphing the answers on the same number line. So for number 3, I'm going to work on getting that x by itself. So I have 6x is less than negative 6. And we want to get the x by itself, so we divide by 6. We have negative 1. X is less than negative 1. On the other side, we're going to add 8. So I have 3x is greater than or equal to 21. Divide by 3, and I have x is greater than or equal to 7. So I have 2 separate answers, but together it's one answer. So it's x is less than negative 1 or x is greater than or equal to 7. Now, when you go to put them on the number line, again, make sure your smaller number is on the left, your larger number is on the right. X is less than negative 1 would be an open circle, and less than negative 1, we're going to the left. X is greater than or equal to 7 would be a closed circle, and greater than is to the right. All right, so we have one more of these disjunction problems. So again, I just separated the two sides so that I don't confuse them or anything. So I want to work on getting this n here by itself. So we're going to add 4. So now I have 4n is less than negative 20 divided by 4. N is less than negative 5. Or, and then we can do the one on the other side here. Now on the other side, all I have to do is divide both sides by negative 9. But remember, anytime you divide an inequality by a negative or multiply by a negative, you have to reverse the direction of that sign. So the other part of this answer is n is greater than or equal to negative 2. So now we want to put these on the number line. So we have negative 5 and negative 2. If you want to put negative 3, negative 4 in the middle, you can. It's not necessary though. N is less than negative 5 will be an open circle, and the number's less. We're going to go to the left. And n is greater than or equal to negative 2 will be a closed circle, and greater than goes to the right. And again, in OR problem, those arrows kind of look like little warps. Okay, and then finally we have a couple word problems here at the end. So again, we're talking about certain things being in between, maybe like a minimum and a maximum of something. So in those cases, there are conjunctions or and problems, and you want to put a variable in the middle of the two extremes. So in this first example, it says, as the moon orbits Earth, the closest it ever gets is 221,463 miles. But the farthest it ever gets is 252,710 miles. So write an inequality that represents the various distances. So my distances have to be between these two values. So at any given point, if you were like, how far is the moon from the Earth right now, we know the smallest possible distance it would ever be, the closest it ever gets, is 221,463 miles. But the farthest it ever gets is 252,710 miles. Now, if you always put the smaller of the two numbers on the left and the larger of the two numbers on the right, your inequalities are always going to be less thans, or the ones that look like an L shape. And in this case, both of them had equal two numbers on them because you were able to you were able to be equal to that distance. That was the shortest and the farthest. So it could equal that, but it would, that would be kind of like the cutoff. Okay, so then the next problem, it says, the first Ferris wheel ever built was designed by the American mechanical engineer George Ferris for the use at the Columbian Exposition or World's Fair in Chicago, 1893. Later, it was used at the World's Fair in St. Louis in 1904. It had a diameter of 250 feet, and each of its 36 cars could hold 60 passengers. Write an inequality that represents the number of people on the single Ferris wheel. So first of all, the minimum number of people that could be on the Ferris wheel would be what? 0. You can't have negative people. That doesn't make sense. So the least amount could be 0. So now we need to figure out, well, what's the maximum number of people that could be on that Ferris wheel. And that's the number that's going to go there. And we know the number of people have to be greater than or equal to 0 or less than or equal to whatever the most people are that fit. Now, they give us a lot of information in this problem, but the only thing you really need is that there's 36 cars. Each one can hold at most 60 people. So if you just multiply that out, you end up with 2160. So 2,160. And so that's all you would have to do to set up your conjunction or your and inequality. Okay, number 3, you are a state patrol officer who is assigned to work traffic enforcement on a highway. The posted minimum speed limit is 45 and the posted maximum is 65. You need to detect vehicles that are traveling outside the posted speed limits. So there's 2 groups of people that you might give a ticket to, right? So one group of people might be doing less than 45 miles per hour, right? Those people are driving so slow that they could actually cause an accident because it's way too slow for a highway. The other kind of people you're looking out for are those that are going greater than 65 miles per hour. So there's 2 groups of people that are not driving a safe speed. So if you're determining a safe speed is between 45 and 65 and equal to those speeds would also be considered safe. But anything below or less than 45 miles per hour or greater than 65 miles per hour would be considered unsafe, and therefore you could give them a ticket and pull them. Okay, and then finally, you have $4.25 to spend in an arcade. Some games cost 75 cents to play and others cost 50. You decide to play 2 games that cost 75 cents, right, and solve an inequality to find the possible number of 50-cent games you can play. So the key with these kind of problems is you don't have to spend all your money. So you want to know how many can you do at the most, but maybe you don't feel like doing that many and you're going to just bring home some change, right? So we're going to have the 75-cent games, right? And we're going to play 2 of those. Plus, we have the 50-cent games, and we're going to play X amount of those. And that all has to add up to a price or a total cost that's less than or equal to how much money we have. We can't spend more money than what we have in our pocket. So first we can calculate how much money we're going to spend on the 75-cent game since we know that there's 2 of them that we really want to play. So 75 cents times 2 is $1.50. And then we still have the 50 cents games times X, and that still has to be less than $4.25. So what would you do? You would want to figure out how much money you have left after you play the 2 75-cent games. How much money do you have left to put towards the other type? So you would subtract the $1.50 that you know it's going to cost you for the 75-cent games. And then you can say, okay, well, I'm going to have $2.75 left to spend on the 50-cent games. Well, how many, if we divide 50 cents into that, how many times will 50 cents fit into 275? So you should get 5.5. And you're finding the number of games. Now, this says that we can play less than or equal to 5.5 games. But there's a problem with that. We're talking about video games, and you can't pay for half of a game. So that means that your X is really less than or equal to 5 games. So sometimes you have to keep in mind, what exactly are you finding out? Like, what is it representing? Is it money? Is it people? Is it games? Is it an object? And then you may have to alter how you round your answer based on that. All right, so hopefully these going over these notes helps. Let me know if you have any questions. Thanks.